So another thing we're going to take a look at in order to investigate or consolidate this idea of a limit is the Fibonacci sequence. So Fibonacci was a famous mathematician, and he came up with this unique sequence of numbers, and it does some strange things. So this Fibonacci sequence is a recursive sequence. A recursive sequence means you look back to previous terms to generate more term. So each number of the sequence is the sum of the two numbers preceding it or before it. Formally, this can be written as, so this means term 1 is 1, term 2 is also 1, and then any term, so let's say term 3 in this case, would equal term 2, the one that comes before it, because n minus 1 is 1 before it, plus term 1, the term that comes 2 before it. And that's why we need the first two terms, because without those two, we can't look back and grab terms. So I'm going to create or start to create the Fibonacci numbers. So the first term is 1, the first term is 1. So term 3 means I look back and grab the two numbers before it and add it. So that would be 2. Term 4 would be I look before it, grab just the first two numbers, the two numbers closest to it and add it. The next term, I would grab the two numbers before it and add them. So you are going to go down and complete that list. A ratio, remember, is another way of saying a fraction, which is a division. So it wants a ratio of consecutive terms. So you take any term and divide it by the term before. So I can't do a ratio for term 1 because there's no term before it to divide. So I'm actually going to skip that one. For this one, I'm going to do 1, divide it by 1, gives me 1. This one, I'll do 2, divide it by 1, that gives me 2. For this one, I'll do 3, divide it by 2, that gives me 1.5. And I'm going to repeat this process. So you need to first find all the terms by adding the 2 before it, and then find all the ratios by taking each number and dividing by the number that comes before it. On the back, it's asking you to create a new sequence from the ratios obtained in question 1. That means you're going to grab all your numbers here and create a sequence. A sequence is just a list of numbers separated by commas. So it's going to start 1, 2, 1.5, on and on and on. So that's term 1, that's term 2, that's term 3, your next one would be term 4, term 5, etc. Because question 3 says create a plot of the sequence from question 2. You're going to do a beautiful, nice plot. I'm just going to roughly sketch this to get going, where the term number is the independent variable. So we usually use n as the variable to represent the term number, and that would be 1, 2, 3, 4, etc. And the value of the ratio is the dependent variable. Those are these numbers up here. So 1, 2. So term 1 would be 1. Term 2 would be 1.5. Term 3 would be whatever you get. So you're going to create a graph of those. Then number 4 says, does the sequence of ratios of Fibonacci numbers have a limit? So hopefully you'll be able to see by your graph if it's just shooting off to nowhere or if it's converging towards a number and there is a limit. Also feel free to Google Fibonacci sequence and you'll find some information about the limit there as well.